Moving on to Chapter 2, the mathematics of power. So in all the elections we've studied so far, we've used one voter, one vote method, where everyone's voice counts equally. But sometimes we recognize the fact that certain voters should have a greater say over the outcome than other voters. In this case, we might give that particular voter more than one vote. So this general principle is called weighted voting. Where do you see weighted voting used? Where one person has more of a say than some other people? The Electoral College, that is like the classic one. Where some states get more votes than other states. Depends on the population of the state. Anywhere else? Yeah, in families for sure. You know, parents often have a larger say over decisions than children. On a company's board of directors or a company's shareholders. The more stock you own, the more of a say you get in decisions made for the company. Yeah? Uh-huh. Do some people get more votes than others? Some people's voices count more than others? No. I mean, that's certainly possible. If what? That's true. That's true. But you're using your power to influence people rather than just having it, right? You have without having to change other people's minds, which is a little different than what we're talking about. Okay, so in this chapter, we're going to study the math of weighted voting. Since the purpose of weighted voting is to give various voters different amounts of influence, we're going to study how to mathematically measure power. So this is just a little intro to weighted voting. A weighted voting system is one in which the voters are not necessarily equal in the number of votes they control. We're only going to consider voting on motions, that is yes or no questions, but keep in mind that any vote between two choices can be framed as a yes or a no question. So it doesn't have to be a yes or no question, it's just a vote, it has to be between two choices. Okay, so these are the three elements of a weighted voting system. We have players, and we're going to use little subscripts to denote the different players, player 1, player 2, player 3, up to player n. However, we're going to have n players. And the weights, we'll use W1, W2, W3, up to Wn. They're going to represent the weights, that is, the number of votes controlled by each of the players, player 1, player 2, player 3, respectively. And then the quota we'll call Q. That's the minimum number of votes required to pass a motion. This is usually a simple majority. It takes a majority to pass a motion, but there are times when it's not a majority. Can anybody think of examples where it takes more or less than a majority to make a decision? Hiring somebody? Sure. Yeah. Yeah. When is that? There's a specific place where that happens. Yes, amending the Constitution requires 2/3. Juries have to be unanimous. They can't decide guilty or not guilty without a unanimous decision. You need another two. You need 2/3 in another situation that has to do with our government. Yeah. To pass a law. Say that you said something. To overcome a veto. Yeah. So if Congress passes a law, it takes just a majority to pass a law. But if the president vetoes it, it goes back to Congress, and if they can pass it with 2/3, it's veto proof. So 2/3 of Congress makes a law veto proof. So those are all good examples. And this hiring someone, if you're on a hiring committee or you work for a company, they could set this anywhere they want. They could say this is a majority, this is 60%, this is a 2/3 majority. They could require 75% agreement. So this could be anything decided by the company. Okay, so this is our notation for a weighted voting system. It's just a way of taking a long paragraph description of a voting power and condensing it down into one short little thing that looks like this. So the first, we always use the square brackets. The first thing we put in is the quota, Q, how many votes it takes to pass the motion. And then you put in the weights of all the players from largest to smallest. So the person with the most votes goes first, and the fewest votes gets put in last. So here's an example. We have 4 friends. They decide to start a company. It's going to take $200,000 of capital to get the business off the ground. Player 1 puts in $80,000. Player 2 contributes $70,000. Player 3 contributes $30,000, and player 4 puts in $20,000. The friends decide that those who contributed more money should have more of a say in business decisions. So they decide that every 10,000 contributed is going to be 1 vote in all business decisions. And we set the quota at 2/3 of the total votes. So how many votes are in this partnership? 20. Yep, we put in $200,000. Each $10,000 equals a vote. So there are 20 votes total. And what is the quota, Q? $11 would be a majority, but we're requiring 2/3. So you need at least 2/3 of 20. Calculator. Let's do 2/3 times 20 is 13 1/3. But you can't have 13 1/3 votes, so we'll say 14. So the quota is 14, and we get that by taking 2/3 times 20, which is 13 1/3, which is impossible. You can't split your vote up. So we say it takes 14 votes to pass a motion. So using our notation, I want to describe this partnership mathematically. So we use square brackets. We put the quota first, 14, the number of votes required to pass a motion, colon, and then we put the weights of each players in descending order. How many votes each player has. So who has the most votes here? Player 1, and they have 8 votes. They put in $80,000. Player 1. No. The subscript doesn't change. Player 1 is just naming the player. So we just put in an 8. Player 1 has 8 votes, so I put 8. Then who has the next number of votes? Player 2 has how many votes? Seven votes. One for every $10,000 they put in. And then player 3 has 3 and player 4 has 2. So we had a whole paragraph to describe what was happening and how the decisions are going to be made in this business, and we just condensed it into this really short notation. Yes. Uh-huh. Yeah. Yeah, we're going to do a bunch of examples. It's coming. See how to measure how much power they actually have. All right, so what if we lowered the quota in this example where it 14, 8, 7, 3, 2. I'm going to lower the quota to 10, so it only takes 10 votes to pass a motion. What happens here? Yes. Yeah, so player 1 has a lot more power when you lower the votes. But what if player 4 was the one who agreed with him? He'd have 10, right, which is enough. It would tie, yeah, and that would be, I mean, what's the point then, right? You can't ever make a decision. So there's a possible tie here. 8 and 2 versus 7 and 3. This is not a good situation for decision making, right? So we would call this gridlock. Can't ever get the decision made. Now, what if I made the quota 21 votes? There aren't 21 votes, so this is another case where we can't make a decision, right? So there aren't enough votes to make a decision. This is another bad situation for voting. So where do we want to set the quota? You know, we want to avoid ties, and we can't set it higher than the number of votes. So where do I want to keep that quota? Between what two values?
51.99.
Yeah, so we want it to be less than the total number of votes, right? Or equal to, yes, because we could require a unanimous vote. Yep. And we want it to be bigger than what? Yeah, we want it to be at least a majority, so bigger than half the total number of votes over 2. And it would have to be strictly bigger than that, not equal to. Because if it was equal to, you could have ties. So I'll put V is total votes. Okay, so when you're designing a voting system, you're always going to set the quota somewhere between a majority and unanimous. All right, so 19, that's somewhere between a majority and unanimous. What are the consequences of making the voting 19 here? Yep, so this is actually, might as well be 20.
I don't think you can get that total with the number of votes.
Exactly, right. Might as well be 20 because it would require a unanimous vote to get 19. would require a unanimous vote to get your 19. So really, in this case, everyone has equal power. Even though player 1 has 8 votes and player 4 only has 2, everyone has to vote unanimously to meet the quota, which means everyone really has equal power. But what if I made, oh, so here's a new voting system. 11 is the quota, and then we have 12, 5, 4 as the weights. What are some practical implications? Player 1 is called a dictator. They get to do whatever they want. Pass the motion, not pass the motion. It is entirely in player 1's hands. There is nothing player 2 or player 3 can do about it. Player 1 gets to do whatever they want. Okay, so here's another example. 4 friends are going to go into business together. 3 invest 10,000, and the 4th, it comes up a little short. He only can invest 9,000. Each 1,000 invested equals 1 vote. The quota is set at 75% of the total votes. All right, so how many votes are there altogether? 19. Okay. And what's the quota? Oh, yes, you're right. 3 invest 10,000. 1 invests 9,000. So that's 39 votes. So what's my quota? 75% is the quota, so that's 75% of the total votes. So I do 0.75 times 39, 29.25 votes. We'll just say 30. It takes 30 votes to pass a motion. So we want to describe using our mathematical notation, square bracket, quota, and then the weights. What are the weights of the 4 players? Great. The first 3 each have 10 votes. And player 4 has 9 votes. So imagine you are in the shoes of this business. You're one of the investors. In particular, imagine you are this investor.
You hold all the power, even though you have the most.
Really?
Oh no, actually, you don't have any power, do you?
You don't have any power. The only way to get 30 is if players 1, 2, and 3 team up. So basically, it does not matter what player 4 says. So player 4 has 0% of the power. We call player 4 a dummy. Just a placeholder. They don't have any say. Right. An investor with no decision-making power. Okay, how about this one? What if I have a quota of 12 and I have 9, 5, 4, 2? Any practical implications? Who has power, who doesn't? Yeah, so player 2 plus player 3 plus player 4 is less than 12 votes. It's only 11 votes. So even if they team up, I can't pass a motion. So The only way to pass a motion is if player one is on board. If any motion wants to get passed, you gotta lobby player one. They are required. So player one is required to pass anything. So we call that veto power. Player one has the power to block something. If there's a motion on the floor and player one doesn't like it, they can keep it from passing. But player one's not a dictator. They can't pass a motion by themselves. They can't say, I want this to pass, thus it will be, right? But they can stop something from passing. So we say player one has veto power. They have the ability to block a motion. Okay, so some conclusions. Was anything surprising to you in any of these examples? Like particularly this one? Yeah, that someone who has a very close number of votes, it looks like the power is relatively even, yet it's not, right? Someone can have just no say. And then also, we have examples where the power looks very different, right? The power has wide distributions, but is relatively equal. So my conclusion is that the number of votes is not necessarily indicative of power, right? Just because someone has a lot of votes doesn't mean they have a lot of power. And just because someone has few votes doesn't mean they have little power. Because we had this example at the beginning where it looked like, according to the number of votes, player 4 has very little power, but it turned out everyone in this example has equal power because it required a unanimous decision. So you can have a few votes and a lot of power. You can have a lot of votes, like here, with the 9, and no power. So just counting the number of votes you have is not a good measure for how much power you have. So you have to come up with another way of measuring power. Number of votes does not equal amount of power. So this is where the math comes in. We're going to try to come up with a way to measure the amount of power you have. Because just counting the number of votes is not good enough. Okay, so the first way that we're going to measure power is called the Banzhaf power index. The weights of a player can be deceiving. Sometimes a player with a few votes can have as much power as someone with a lot more votes, and sometimes two players with almost the same number of votes can have very different amounts of power. So this deceptiveness happens again in this example. We have the Parliament of Icelandia that has 200 members. The Red Party has 99 seats. The Blue Party has 98 seats, and the Green Party holds 3 seats. Decisions are made by a majority vote. That is, it takes 101 votes to pass a motion, more than half. We're going to assume that members always vote along party lines. We want to describe this parliament mathematically. Okay, so we use our square bracket. We put in the quota, colon, and then the various weights. So the highest one is 99. Then we have 98 and 3. So what do you think about this system? Who has power? Who doesn't have power? The little guy has all the power?
No, because even if the 98 and the 3 are
98 and 3 is 101.
Determining factor. Really?
So
Well, you could either get it a determining factor or no factor.
yeah, if 99 and 98 get together. So I think that you're all thinking like according to the United States, red and blue, who are always against each other. But it's possible that they could align and the Green Party could think something else, right? There could be a tie?
Not that I can see.
Mm-mm. So in order to pass a motion, who needs to team up in order to pass a motion? 98 and 3 could team up. 99 and 3 could team up. Or 99 and 98. So I could have, what was red and blue? Red was 99. Okay, so we have red and green, blue and green. Oops, no, switch that. Blue and green, red and green, or red and blue. So these are the three ways you can pass a motion. You just need any two of the parties to agree, and you get to pass the motion. So what does that say about the relative power of the three parties? It's pretty even. Yeah. Even though the Green Party only has 3 votes, they matter just as much as the other two parties. Because it requires 2 of the 3 to pass a motion. Doesn't matter that when these two team up, they have a lot of votes. Doesn't matter. Because when these two team up, they have enough votes. Okay, so a little vocabulary. A coalition is any set of players who might join forces and vote the same way. Since coalitions are sets of players, we're going to use something called set notation to describe them. And all that means is we put them in a list in curly brackets. So when we talk about a set of players or a coalition, we put curly brackets and the players in there. A coalition that has all the players in it is called the Grand Coalition. Now, a winning coalition is a coalition or a team of players that has enough votes to win. Any other coalition is called a losing coalition. And critical players, this is a really important one. A critical player is a member of a coalition who, if they left the coalition would no longer have enough votes to win. So a player is critical if you can't let them leave, right? If they leave, you no longer are a winning coalition. So let's take a look at the Icelandia example again. So we had 3 winning coalitions. We said red plus blue, red plus green, and blue plus green. And there's one more winning coalition. What would it be? All of them. If they all agreed, of course, they would pass the motion. Okay, so the weight. Red plus blue, that was 99 plus 98, which is 197. Okay. Who's critical? Both, yeah. If either of them left the coalition, the one remaining would not be able to pass a motion. They're both critical. Neither can leave. So red and blue are both critical. Now the red plus green coalition, that's 99 plus 3, which is 102. Who's critical in the red and the green coalition? Both. Neither one can leave. If either leaves, they no longer have enough to pass. Blue and green, that's 98 plus 3, which is 101. So they just get to the quota. Who's critical? Both. Now with all 3, I have 99 plus 98 plus 3, 200 total votes. Who's critical? Can red,
9 or 98.
if red walks away, if red says, I'm through with you guys, I'm not part of this team anymore, red's gone, can blue and green still pass a motion? Yep, then red is not critical. Okay. So if blue walks away and says, forget you guys, can red and green still pass? Yes, red and green can still pass a motion, so blue is not critical. If green walks away, leaving red and blue, can they pass a motion? Yes, that means that green is not critical. So no one is critical in this coalition. Any of the three could walk away. It wouldn't matter. They could still pass a motion. All right, so how many times is each party critical? Yeah, all three parties, red, blue, and green, they're each critical twice. Okay. Each party is critical 2 times. So there's an argument to be made that the 3 parties have equal power because they are critical same number of times, despite the fact that G only has 3 votes. So the Banzhaf power index is based on the insight that a player's power comes from how often that player is critical. So in the above example, each player had an equal amount of power, 1/3 of the power. So here's sort of a step-by-step instruction guide for how to compute the power index for each player. First, you have to make a list of all the possible winning coalitions. Then, within each winning coalition, you determine which are the critical players. So we did this for the Icelandia example. We made a list, we determined who was critical. Then you have to count the number of times player 1 is critical. That gives a number we call B1, and we call that the critical count. You repeat that for each of the other players. You find the critical count for each player. How many times is each player critical? So this part we've already done. Okay? We did steps 1, 2, and 3 in the Icelandia example. We wrote out all the winning coalitions. We determined who was critical. And then we got the critical count for each player. Each party was critical twice. So we have the critical counts. Then we move into the last 2 steps here. You add all the critical counts together, and we call this number T. Okay, so for Icelandia, T is 2 plus 2 plus 2, adding all the critical counts, because each party was critical twice. So you get 6. Then you find the ratio B1 over T. Each player's critical count divided by T. So for red, we would do 2 over 6. Their critical count divided by 6 total critical counts, which is 1/3 of the power. Same thing for blue and green. Blue would also be 2 over 6, and green would be 2 over 6, giving each party 1/3 of the power. When you write out a list of all the power percentages or fractions, that's called the power distribution. Yep, you can leave it in fractions, or if you like percentages, you can change these to percentages. It doesn't matter. They just express the same thing. One thing you should be aware of is that when you're checking answers in the back of your book, they often leave it as fractions, but they'll reduce them. So if your answer is 2 out of 6 and you see the back of the book has 1 out of 3, just be aware that they just reduced the fraction. There's equal values. Okay, so we want to find the Banzhaf power distribution for this weighted voting system. Quotas 4, the voting weights are 3, 2, and 1. So we'll call this player A, player B, and player C. So I need to list all the winning coalitions. So who can team up and get the quota of 4? Yep, A and B, A and C, and all 3, A, B, and C. B and C only have 3, so they don't have enough. All right, so for A and B, who's critical? Both. If either A or B left the coalition, the remaining member would not have enough votes to reach 4. So they're both critical. Neither one can leave. How about A and C? Both critical. Neither one can leave. A, B, and C? Okay, so let's go through it one at a time. A, if A left, B and C would have how many votes together? 3. Is that enough? No, that makes A critical. A can't leave or there aren't enough votes. How about B? If B leaves, do A and C have enough left? Yeah, they have 3 and 1, so they have 4 votes together. That means B is not critical. B can leave, it's okay. How about C? Can C leave? Yeah, C can leave. A and B would still have 5 votes, so that's fine. So A is the only critical player in that coalition. So now we get the critical count for each player. How many times is A critical? 3. How many times is B critical? Once. And how many times is C critical? Once. So my total critical count, T, is 3 plus 1 plus 1, which is 5. Then you take the ratio. For each player, you take the ratio of their critical count over the total number of critical counts. So A is going to be 3/5. B is going to be 1/5. And C is going to be 1/5. This is the power distribution. A has 3/5 or 60% of the power. B has 1/5 or 20%. C also has 1/5 or 20%. You can use percentages if you like them, or you can just leave the fractions. Doesn't matter. So is that surprising, giving the votes? 3, 2, 1? A little bit, because 2 and 1 look like B and C would have different amounts of power, but it turns out they're equal. Okay, so I would like you to try this one in your groups. Okay, so let's discuss it together. So our weighted voting system, we write out with a square bracket. And I have 10 votes. It takes a simple majority to pass a motion. So what's my quota? 6, right? More than half. And then my votes are going to be 4, 3, 2, 1. So to find the Banzhaf power distribution, I have to come up with all the winning coalitions. So let's call these A, B, C, and D. So who can team up? Let's just do all the 2-player coalitions first. What 2 players can team up to get at least 6 votes? A and B. Anyone else? A and C. For 2 players. Any other sets of 2 players that can get the quota? Okay, so let's try to talk about 3 players who can get the quota. B, C, and D. They team up and they have exactly 6. A, B, C. Yep. Yep, they have 7. A, B, D. Yep. I heard some oh no's there. Yes, and now we have the 4-player coalition, A, B, C, D. All right, are there any more? Did I miss any? Okay, I think that's good. So then I have to go through and find out who's critical in each coalition. In A and B, in the AB coalition, who's critical? Both. Neither can leave, or it's no longer a winning coalition. How about A and C? Both. All right, B, C, and D. Yeah, if anybody leaves, they have exactly 6 votes. So if anybody leaves, they're not going to have enough. So they're all critical. How about A, B, C? If A leaves, there's only 5 left, so A is critical. If B leaves, there are 6 votes remaining, so B is not critical. And if C leaves, there are 7 votes remaining, so C is not critical. How about in A, C, and D? Okay, A is critical. There's only 3 left if A leaves. If C leaves, there's only 5 votes remaining, so C is critical. But if D leaves, there are still 6 votes, so D is not critical. How about an A, B, D? Who's critical? A is critical. There's only 4 left if A leaves. B is critical. There's only 5 left if B leaves. But if D leaves, there are still 7 votes. So D is not critical. All right, how about an A, B, C, D? No one is critical. If A leaves, there are still 6 votes. And if anyone else leaves, there's more than 6 votes. So there are no criticals in the Grand Coalition. Okay, so now each player will calculate their amount of power. How many times is A critical? 5. Out of how many total critical? 12 criticals altogether. So A has 5/12 of the power. The 12 is you count all the green circles. You add up all of the criticals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So A has 5 of the 12 criticals. How many criticals does B have? 3. So B has 3 out of 12. 13, you must have an extra one circled. C is also 3. And D has 1/12 of the power. This is the Banzhaf power index. When you find out the power that every player has and put it in a list, we call that the power index. So who has the most power? A. Did you find these results surprising? Okay. Yep. B and C had different votes because it went 4, 3, 2, 1. So it looked like all 4 players had unequal power, but it turns out that B and C are equal. 3 votes and 2 votes have the same power. Good. Okay, so for the remainder of class, I'm going to have you work on this activity about frontier power. So Frontier High School has a school board with 3 members from Deerfield, 2 from Sunderland, 2 from Whately, 2 from Conway. For a motion to pass, you need a majority of the board to vote yes. I want you to use this situation to answer the remaining questions about power in the school district.